So here we go for the second lecture in a series of advanced level problems on friction. As said before, these are problems which illustrate Newton's laws of motion, taking into account the frictional forces which come into play between surfaces in contact. The problems may vary in difficulty level, and therefore I shall be using 1 dot, 2 dots or 3 dots to denote the ascending order of difficulty level of a problem. If you remember the question, they have said, let me say it here once again, at the end of upward journey, time was capital T. And at the end of return trip, that is upward plus downward journey together, the time was k plus 1 into capital T. And therefore, I might write down the time for downward journey alone, that is delta T, is coming out to be the final time k plus 1 into capital T minus the time taken for the upward journey only. And this is coming out to be kt plus t minus t. T is cancelling out. That is k into capital T. So remember, for the downward journey, the time taken was delta T, that was k into t. Let me put the question back in the previous position, and we are going to apply this kinematic equation here. Now, during the downward journey, as the block returns to the very initial point of projection, the displacement has the same magnitude as this given by equation number 2. But this time, the block is traveling downward, and that is, according to my sign convention, that's negative direction. So I shall take value of delta x to be, referring to equation number 2 here, you are seeing this is the magnitude. But I don't forget to put a minus sign sticking to my sign convention. So it's minus u square divided by 2g into sine theta plus mu k cos theta. Come to the right hand side. At the beginning of the return trip, u was 0. So the first term vanishes, plus half. The value of a now, a dash, as we just now obtained, so I'm putting this value here, that is minus g into sine theta minus mu k cos theta into time of travel already found delta t, that is kt here. So I write k into t. This is whole squared. So this is the equation once again. I repeat, I am sticking to the same sign convention. Therefore, in downward journey, displacement becomes negative, acceleration is negative, time of travel is kt as found little earlier. Let's see what we get from here. In the next step, as you can see from both sides, this 2 is cancelling out, and we are having k square into t square. Just do with me and corroborate my steps. K square into t square, and also the minus sign I can see is going off on both sides. So it is u square divided by g square into sine square theta minus mu k square cos square theta. Just check it. We have got k square t square is equal to u square divided by g into sine theta plus mu k cos theta, then again divided by g into sine theta minus mu k cos theta. Therefore, I got in denominator g square into sine square theta minus mu k square cos square theta. Once we reach this step, we recall equation number 1 obtained during the upward journey consideration and put this value of capital T in this last result. So what we get? We are getting k square into, well, I am putting the value of t straight away here and squaring that. This is giving me u square by g square into sine theta plus mu k cos theta whole square, isn't it? That is putting the value of t from here into this. Right hand side remains the same, which is u square divided by g square into sine square theta minus mu k square into cos square theta. From both sides, u square cancel out, g square also cancels out, and you can see in both these terms on left and right, sine theta plus mu k cos theta is common. Therefore, I can get rid of 1 here, and this side I am getting simply sine theta minus mu k cos theta. Just check this. So, eventually I am getting that k square is equal to sine theta plus mu k cos theta divided by sine theta minus mu k cos theta.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.